Steel Dynamics is a leader in the mini-mill steelmaking industry with a focus on value-added products with demanding quality requirements. And at the heart of the mini-mill process, a more environmentally friendly way of making steel is scrap steel. Lots and lots of scrap steel. In fact, about 75% of the material SDI uses to make new prime steel consists of scrap steel that is often left to rust in junkyards or litter the countryside. SDI also owns OmniSource, the second largest scrap recycling company in North America. And that's where our story begins, at an OmniSource facility in Indianapolis. OmniSource collects and processes ferrous scrap and non-ferrous scrap at more than 70 facilities around the country. Here at one of OmniSource's 5 facilities in Indianapolis, a gigantic shredder reduces entire automobiles and other large pieces of scrap into smaller sections that will fit into the flat roll division's electric arc furnaces. After the scrap is shredded, giant magnets separate the ferrous materials from the non-ferrous. Non-ferrous scrap is conveyed away for further sorting. Just as in the mini-mill steelmaking process, nothing goes to waste. At a visual inspection checkpoint, employees remove any non-ferrous scrap that's hung up with the ferrous material. Next, the scrap is shipped to the Flat Roll Division's mill at Butler in northeast Indiana. The mill campus includes 15 miles of railroad track capable of handling 700 rail cars at one time for incoming scrap and outgoing steel shipments. The mill also receives 200 to 300 truckloads of scrap and other raw materials every day. It's a 24/7 operation that runs 365 days a year. 3 30-ton scrap cranes and large front loaders facilitate moving the scrap around, in and out of rail cars and trucks, and to the scrap bay at the edge of the melt shop, where large magnets lift up the scrap and place it into a charging bucket. Scrap is loaded into the charging bucket according to grade to achieve the exact chemistry necessary for our steel products. Each furnace heat consists of 175 tons, with at least 75% of it scrap, and about 10% liquid pig iron from Iron Dynamics, a division of SDI on the Flat Roll Mill campus. SDI is also making iron-rich units with a pioneering process at Mesabi Nugget in Minnesota. Both IDI and Mesabi use iron-making methods that are far more eco-friendly than traditional blast furnaces. Mini-mills use electric arc furnaces, or EAFs, which require much less in the way of natural resources versus traditional blast furnaces. For every ton of steel produced by SDI, we eliminate the need for 2,500 pounds of iron ore, 1,400 pounds of coal, and 120 pounds of limestone. And we use significantly less energy in the process. The EAF process also produces 67% less carbon equivalent emissions. In addition, 95% of our scrap comes from within 250 miles of our plants. The charging bucket is moved to a position directly above one of the mill's 2 twin-shell EAFs. The scrap is then released into the furnace, creating some real fireworks. The reason for the explosion is that a portion, about 40 tons, of each heat of molten steel is left in the furnace to keep it hot for the next heat, saving time and money. Once the scrap and pig iron are loaded, the roof of the furnace is closed, and 3 large carbon electrodes are lowered through an opening in the roof. Then, it's showtime. And it's loud, very, very loud. The rods circulate or arc up to 115 million watts of electricity to melt the scrap at a temperature reaching 3,000 degrees Fahrenheit. The power is on for about 35 minutes to complete the melting of each heat, which is a good reason why our monthly electric bill is about $7 to $8 million. Once a heat is completely melted, the furnace is tipped to pour off the slag, a collection of impurities that rises to the top of the heat. The molten steel is then tapped through the bottom of the furnace and into a ladle. The steel then goes to the ladle metallurgy furnace, or LMF, where a variety of processes can be accomplished, including desulfurization and deoxidation. The temperature of the steel can be adjusted with carbon electrodes, and the chemistry of the steel can be changed by reducing some alloy elements and the introduction of others. From the ladle metallurgy furnace, the steel goes to the thin slab casters. On the caster deck, the turret rotates to exchange an emptied ladle with another ladle filled with molten metal. As it goes through the casters, the molten steel, now about 2,800 degrees Fahrenheit, is converted into a continuous ribbon of steel approximately 60 millimeters thick and up to 180 feet long. These thin slabs can be rolled into steel sheet much more quickly, efficiently, and cost-effectively than the much thicker slabs produced at traditional integrated steel mills. Producing slabs up to 64 inches thick, the casters operate at maximum speed of 230 inches per minute and process 9,000 tons of steel in a 24-hour period. Going through a 2,400 gallons per minute spray of cooling water, the slab is completely solid in 24 seconds and has an exit temperature of 2,100 degrees. After being sheared to length, the slab goes through one of two tunnel furnaces where the steel is reheated to 2,150 degrees before going to the hot strip mill. Scale is removed from the slab before it's rolled, with water jets spraying 4,000 gallons per minute at 3,500 pounds per square inch. Slabs are reduced to meet customers' requirements on our 7-stand hot rolling mill. 7 10,000 horsepower motors drive the work rolls in the mill stands, and 4,000 tons of rolling force per mill stand reduces the thickness of the material to as little as 1 millimeter, or 0.040 inches. A new hot band of steel is automatically coiled. On average, each coil weighs about 22 tons, or as much as 10 cars. In the cold mill complex, coils are chemically cleaned through the continuous pickle line. Operating at 700 feet per minute, the pickle line has the capacity to process 1.6 million tons of steel annually. Pickled and oiled coils can be sold as finished products, galvanized on the hot-rolled galvanizing line and sold as finished products, or further processed through the cold reversing mill. Hot band is uncoiled on the reversing cold mill, where the gauge will be further reduced to as light as 11 thousandths of an inch. Coils that have gone through the reversing mill are usually galvanized or annealed. On one of our two galvanizing lines at Butler, an employee removes the dross, or impurities, from the surface of a zinc pot holding as much as 180 tons of molten metal. SDI's galvanizing lines offer a variety of value-added services, such as inline temper passing, tension leveling, chemical treatment, acrylic coating, and oiling. Annealed coils go through the temper mill and are sold or painted on our coil coating lines. Here we are on the banks of the Ohio River in southern Indiana. Jeffersonville produces hot-dipped galvanized galvalume, acrylic-coated galvalume, and acrylic-coated galvanized steel as wide as 61 inches. In fact, SDI is the only company in North America to make galvalume in widths wider than 50 inches. Before being introduced into the main pot containing galvalume coating, an aluminum zinc ingot is melted in a pre-melt pot that flows into the main pot to maintain a more consistent temperature. Here, a coil of galvalume is checked for surface defects. Jeffersonville is also home to one of our two state-of-the-art coil coating lines operated by the Flat Roll Division. The coil coating lines at Jeffersonville and at Butler give the division a capacity to paint approximately 500,000 tons of steel each year. SDI's Flat Roll Division is the only steel mill operation in the United States that paints its own steel. The 8-story accumulator unwinds a coil, allowing faster continuous coating. Some coils of thinner gauge steel would measure as long as 5 miles if completely unwound. The coil coating line has 3 coaters, 1 for primer and 2 for the top and bottom finish coating, making quick color changes possible. These lines have the most state-of-the-art equipment in the industry, including vision technology, producing the highest quality pre-painted coils available in the world. Whether coils are coated at Butler or at Jeffersonville, the highest standards of quality are maintained through continuous monitoring with leading-edge technology and equipment and well-trained eyes. We recently installed equipment that allows coils to be placed on pallets. Coils placed on pallets are easier to handle for our customers who depend on forklifts to move materials in their facilities. Coated coils are staged for shipment to our customers in a broad range of industries who use our steel in a wide variety of applications. Scrap produced during processing at Jeffersonville is loaded for shipment back to the Butler mill where, you guessed it, the scrap will be melted and used again to make new steel. It's a full circle.